Okay, in this video lesson what we're going to be doing is covering the graphical user interface functionality. It's part 3, mouse event handling.
Yep.
We've got the core graphics engine in place inside the level editor, and it's functioning. Now what we need to do is set it up so that a designer can use the mouse to start drawing in the different items that are placeable within a level,
Right.
such as walls, player start, and evil monkey start.
Yep. So basically there's going to be 2 steps. Again, we're going to add the necessary functions in the header. So we're going to have an on motion and on mouse left. These are both mouse handling functions where motion, every time the mouse moves, this function is going to be called. And on mouse left, anytime the user presses the left mouse button, something's going to happen.
Okay.
And we're also going to add some variables that will help in these mouse handling functions. And these are going to be added into the stretch game view. Well, they're going to be updated in the stretch game view function.
Okay.
Basically, position X and position Y is going to say where on the screen the actual grid is being displayed. This will allow us to calculate where exactly the mouse is located, which cell.
Okay.
Grid width and grid height is going to say on screen what's the size of the grid. And mouse grid X and mouse grid Y are going to be used to remember where exactly the mouse is located.
Okay.
Well, which grid cell the mouse is located on.
Gotcha.
Okay, so with that general overview out of the way, let's go over to the appframe.cpp file. Well, let's start with the header file. So inside the header file, what do we need to do? Well, let's go ahead and add the on motion and on left click. So down here, let's do our void on motion wx mouse event and our void on mouse left wx mouse event and event. And then we're just going to add our game variables down here. So let's go all the way down to here. And the new ones I was telling you about, so we have our position X, which stores the current location on the screen of the grid. And we have our grid width and grid height, which stores on screen the size of the grid width and height. And finally, which cell our mouse is really located on. So that's going to be the grid X and the mouse grid Y. So with that in place, let's go over to the app frame and kind of start adding the functionality needed to make this guy work. But the first thing is, of course, we're going to have to make it so that the mouse event handlers are actually called. Excuse me. So right over here where we're handling the size event and paint event for the game window, let's add 2 more things. Back in the constructor. Let's add 2 more, and that's going to be an event motion. That's going to be, of course, channeled to the on motion function. And let's paste this again, and this is going to be the WX EVT left down. So the left mouse down. And this is going to be, of course, handled to the on mouse left.
Okay.
So simple enough. Now what we're going to do is actually implement this. So let's go down to the very bottom here and create our new functions here. So the first one's going to be our app frame on motion. And it's inside of here that we're going to calculate where the mouse is actually located on the grid. So WX mouse event and event. So the first thing we're going to do is get the current mouse position. So WX point MP equals event dot get position. So we can get exactly where the mouse is located inside the game area. Now we're going to have to test to see if the mouse, first we're going to test to see if the mouse is actually inside the grid. So we're going to say if mp.x is greater than or equal to position underscore x, and that's, of course, as I mentioned before, where the grid is located inside the game area.
Okay.
And we'll define this in just a second inside the stretch game view function. So we're just going to pretend like it's already set. So we're also going to make sure that mp.x is less than or equal to position underscore x plus the grid width. We also, and want to make sure that the mp.y, the mouse position in y, is greater than or equal to the position in y of the grid, and the position in y, the position of the mouse in y, is less than or equal to the position in y plus the grid height. Once we're positive of that, once we're sure that it's inside the grid at some point, we need to calculate where exactly the mouse is on which grid cell. So let's create 2 temporary variables, a temp x and a temp y, that calculates this. So let's take the mouse position and minus it by the current position of the grid on the screen, and divide it by the grid width divided by the current level's grid X. Does that make sense?
Okay, some people may have a little bit of a hard time following that one.
Okay, so basically what we're doing is taking the mouse position's X and the mouse position's Y, the mouse position's X position, and minusing that by the current grid position's X.
Okay.
And when we divide by this, basically we have the grid width, and the current level, this grid X is a value between, say, if we create a 10 by 10 level, that's going to be 10. So by dividing this by that, we get the size, the width of each cell.
Right.
And by dividing that by the current position, we're going to get exactly which cell he's on in X.
Gotcha.
So let's paste this in here and do exactly the same thing for Y, except changing everything from X to a Y. And all widths to a height. Done.
Okay, cool.
We're also going to check, because inside of here, if we're on a new grid cell, we want to make sure that something is updated, right?
Right.
Well, just to save memory and save speed on drawing stuff, let's check to see if we're at the same place we were before. If we're in the same cell, we don't want to update anything.
Right.
So check to see if temp.x does not equal mouse grid underscore x, which is the last cell that we were in. And temp y does not equal mouse underscore grid underscore y.
Actually,
yeah, my bad. Well, in this case, we want to make sure that they're both not in this exact same location. So I'm sorry, this was supposed to. I'm just kind of. Okay. So if it is a new location, let's update the position of the mouse to the new temp x and update it to here.
Okay.
And at this point, with this updated, the only other thing we need to do is allow the user to drag the mouse to draw items, because we don't want him to have to click, click, click. That's just kind of repetitive and boring. So if event dot, remember we're past a WX mouse event, and inside we have a member function that allows us to check whether or not the left mouse button is down. So if it is, we're going to go ahead and call onMouseLeft, which is a function we're about to create.
Right.
And inside that function is where we actually do the painting, or adding items, or however you want to say it. And let's go ahead and pass the event that was passed to us.
Okay.
So with that, that's going to cover the onMotion function. Let's go ahead and implement the onMouseLeft function. So we have our app frame onMouseLeft, and of course this is past the WX mouse event and event. So the first thing we're going to need to do is, let's see, make sure that the mouse grid X and mouse grid Y does not equal -1. So if mouse underscore grid underscore X does not equal -1 and mouse underscore grid underscore Y does not equal -1, we're going to go ahead and set this, which reminds me, let's go ahead and set this in the constructor to make sure that that's set.
Okay.
So let's copy the mouse grid X and grid Y, go up to where we've been initializing all our variables, and make sure the mouse grid X and mouse grid Y are equal to -1 to begin with.
Right.
So, of course, this is in the constructor. So let's go back down all the way to the bottom in our newly created onMouseLeft function. And if we're currently in a cell somewhere, because that's what we're saying right here, we're going to start out by deciding what do we have selected, which toolbar item do we actually have selected, and depending on that, let's go ahead and draw that and update the information in the grid. So let's create a local variable called selected and default that to 0. And then we'll say if the toolbar dot get tool state, so this gets the current state, whether it's selected or not, of, and you just pass it the ID. So in this case, let's say if toolbar erase is selected, so it's going to return true if that item is selected. So if that is selected, we're going to say selected equals 0, 1, 2, or 3, right?
Right.
Well, let's go ahead and define, say things like tile underscore empty, so that we can use words to describe these indices, so they're not like magic numbers.
Right.
So let's go back over to our app frame, and let's just basically create our enumeration here.
So tile IDs.
Yep. So we're going to create our enum tile IDs. And this is pretty much what we have in our evil monkeys too, a very similar convention here. So tile wall, and we have our tile player, and we have our tile enemy. So like that. So at this point we just need to check every single one of our toolbar items and assign it the appropriate value. So we'll do else if toolbar get cool. Actually, we could just copy this because it's very similar. And for this one, it's going to be our TLB wall. Make sure this is else if, and the selected is going to be tile underscore wall. And let's just copy this and paste this. And this one's going to be the player. So our tile underscore player.
And finally, our enemy.
So TLB enemy and our tile enemy. Else, we're just going to return the function. At this point, if none of these are selected,
right,
we know that something's seriously wrong because these are radio buttons, so one of them should always be selected.
Right.
So just go ahead and return if something like that is going on. Now let's make sure that our back buffer is indeed populated with something.
That exists.
So that it definitely exists. Now let's go ahead and both update the grid X and Y and print the new position, print the new cell.
Right.
So let's create a WX memory DC for this, for our back buffer DC. And let's select it with our back buffer. So back buffer DC.select object. And just so I don't forget, I'm going to go ahead and unselect it as well. And kind of just work in between that. Bitmap. There we go. And make sure null is spelled correctly. So inside of here, let's go ahead and create, well, basically all you need to do is say if the mouse underscore grid underscore X is less than the current level. So let's make sure that whatever grid cell that we're on is actually inside the size of our level. We want to make sure that happens, otherwise, well, we could run into some serious issues. So make sure that it's inside grid X, and mouse underscore grid underscore Y is less than current level grid underscore Y. So if that's the case, go ahead and get the current level's grid, so its grid variable, and assign it at mouse grid X and mouse grid Y the value of the selected toolbar, which is selected.
Okay.
Fairly straightforward, right?
Mm-hmm.
So what we're going to do now, however, is what if selected is going to be our player, right? We only want there to be one player inside of our level.
Place multiple player starts.
Exactly. So right below this, we still want to set our grid item at mouse grid X and grid Y to the selected, even if it's a player. But before we do that, let's make sure that if it is a player that we're trying to place inside of the level, any player that used to be in the level, let's erase it with an empty space.
Right.
So we can say if selected equals 2, loop through all the items in the grid. So just as we did before, the grid's X, and let's do X++. So a simple loop that loops through all the elements. And then we'll say if
find,
yeah, exactly. If we find one inside the grid,
that's a player tile, which is number 2.
Go ahead and delete it. So current level at grid of XY equals 0, which is an empty tile.
Right.
And then because we're drawing this as well, and it's a little bit more efficient to do it this way, let's go ahead and replace that with an empty cell. So let's do a back buffer DC dot draw bitmap. Of course, it's item 0, which is an empty item, and do an X times grid underscore size plus 1, and then a Y times grid underscore size, parentheses size, underscore size plus 1, and of course we do, although it's not totally important, let's just go ahead and end it off.
Okay.
We do not need a mask for that, because it is, of course, the erased item, so it doesn't have a mask.
Right.
So with that printed out, the last thing we need to do is make sure that we actually print whatever item we just created. So same line as here. Let's copy this and at the newly created item, which is mouse X and mouse Y. So let's just change this to mouse grid underscore X and mouse grid Y. So print the background on this current tile and then overwrite that with whatever's selected. Does that make sense?
Mm-hmm.
So just take whatever's selected, that item inside of our items array, and print that out as well. Just in case, like, if they have a mask, we don't see the black behind it.
Right, for sure.
So let's see, with that, exit with that, and we want to make sure that we update everything. So let's go ahead and call stretch game view and our flip back buffer. So there we have it. We have both of the on motion and on mouse left. The last thing we need to do is remember in our stretch game view we need to update the things that we've been using this entire time. So let's just go to our stretch game view. Oh wow, we used it everywhere. Right on the bottom here, let's update the values that we've been wanting to create. So that would be the position in X and the grid width. So let's just go to here and say position underscore X equals, and remember it's been printing it at center.x, so just update this with center.x, and position underscore Y is going to equal center.y. And right here we have our grid width is going to be equal to our stretch size dot get width, and our grid height is going to equal our stretched size dot get height. So hopefully with that everything should be created for it to work. So let's go back and switch over to context real quick before we go ahead and test this out. You'll notice that we added the variables necessary, we added the mouse handling functions in the header, and then we finally implemented them, which is the imaginary step 3 that we have.
Right.
So let's go back to our .NET here, and let's make sure everything works properly.
Well, at least it's not 5 pages long.
There's
2. Yeah,
I have 2 here
and 2 there.
That's pretty impressive. I think we have one more error here. Grid is putting a little arrow here. A completed arrow is usually a good idea. So let's go ahead and run this and see how well we did. So give it a second. Let's go ahead and rebuild it. It seems to have, again, done the magical thing where if you don't rebuild, it's not happy. So just give this 1 second. It takes no time at all. Let's go ahead and run this, and of course it works. So let's create a new package, 10 by 10. So we have this. Now let's left click, and it seems like everything is working properly. Except it is not being updated when we move the mouse. Now this is a very easy fix, so let's exit this out. And right down here we need to make sure that we update the view. So let's go to here and actually update the view. So in fact, update view, if we just kind of recap our own code here, so much code. Just go to our update view function here. You'll notice that at the very bottom we do call stretch game view.
Meaning we don't really need to call it up there.
Right. So right down here in our on mouse left, let's go ahead and just call update view. Give it a second to kind of refresh. Let's run it. Okay, it's definitely a matter of redraw. So let's go to our right here and make sure that everything. I do remember forgetting one thing here. If the mouse position is not inside the grid, we need to make sure that it sets it back to -1, -1. So otherwise, if it's not inside the grid, check to see if the grid has been set to -1. If it hasn't been set to -1, does not equal -1, go ahead and set mouse grid X and Y to -1, and then update the view.
Okay.
So let's compile this, and this should fix that little anomaly we were having there. Let's run this, create our new package. Not quite. We're still having a little bit of redraw issue here. So let me just think here for a second.
Okay, we just did a quick cut. We wanted to go ahead and troubleshoot this off screen so we didn't lose a lot of video time here. And it ended up being
Really stupid.
a very simple problem.
Yeah. Right in our on motion function, we accidentally said and actually this was my fault. It should have been or.
Because Buzz did say the word or earlier.
Yes, he did say or, and I said no. I said and he said no, it's or. And basically went back and forth until I was wrong. So let's change that back to an or and compile this.
Just that one change, and now it should hopefully work okay.
Yeah, and then I will blame Buzz. So let's go ahead and create a new package and check it out. And one other thing I changed when I was troubleshooting a second ago when we were still on screen is I changed this down here in the on mouse left to update view. Remember, this is redrawing everything, and that's the whole point that we have up here where we are just drawing certain things.
Right.
So that's why we had this as stretch game view, which is right, and then we had our flip back buffer.
So just setting that back.
Yeah, so we're just setting back to what we had before. Just when I was troubleshooting, I decided, well, maybe that's what was causing it.
You and that lowercase b.
Yeah, I know. It's like, should it be uppercase or lowercase? I don't know.
Okay, and that should do the trick now.
So if we create a new package, you'll notice that the speed is perfectly fine. We can create levels. And we did forget to set the mask for this guy, and then when it updates, it's going to update it correctly. So let's go ahead and when we place the object, go to the end here and make sure this is set to true, so that it draws the mask appropriately.
Right.
All right, let's just recompile this, and so
Very
look
nice.
at that. And enemies and everything are drawn properly.
Excellent.
Awesome.
And let's go ahead and stretch the window. And very good. Very nice.
Excellent.
Okay, so outside of that small little hitch, everything is now up and functional. So you look back over this one more time, knowing that the and should be an or, and everything should be good. And with that, that's going to wrap up getting all of the GUI functionality in place with the exception of the test toolbar button, which we'll have to get a little bit later on once we get the saving package capability in place, and over in the game the ability to load package and files in,
right.
package and levels. Okay, so with that, that's going to wrap up this lesson. Thanks.